This problem has two Young's modulus and two stepped bar. So we have to model based on that. So let me go for preferences, structural, click OK. Go to preprocessor, element type, add. So since it is a bar type of element, so we are going to add the element link. So link 180, click OK, close. Go to material property, material library. Go to material property, material models. Here you have two Young's modulus. So one Young's modulus is 70 into 10 power 9 Newton per mm square. Sorry, uh, 70 into 10 power 9 Newton per meter square. So, but we are going to follow in Newton and mm. So, converting to Newton per mm square, you are getting 70 into 10 power 3. So, let me proceed. Structural, linear, elastic, isotropic. Young's modulus is 70 E3. Poisson's ratio is 0. Click OK. There is another Young's modulus for this problem. So, go to material, click new model. So, material ID is 2. Click OK. So in this, click isotropic, and the Young's modulus for second material is 200 into 10 power 9. Converting to Newton per mm square, we are getting 200 10 power 3. So which is 200 E3. So your Poisson's ratio is 0. Click OK. So this completes our material property. So in order to enter the area of cross section, go to sections. In this there is a link, click link, add. So material ID is 1 for first area. Click OK. So it is asking what is the section 1. So this is for reference. Let me call this as A1. The link area for A1 is 2400. So let me type 2400. Click OK. So again click add. So material ID is 2 now for second area. Click OK. So the section name I will call it as A2, and the section data is 600 mm square. So 600. Click OK. So we completed adding the material property and the cross section area. Next, go for modeling. Modeling, create nodes. So we have 3 nodes here. So create, go to inactive CS. I'm not entering anything for first node. Click apply. For second node, the distance is 300 mm. So type it as 300. Apply. Third node, it is 700 mm. So let me type it as 700. Click OK. So you have row number 1, 2 and 3. Now let us create elements. Go to elements. Before creating element, the first element which is connecting nodal point 1 and 2 has Young's modulus 1, which is 70 into 10 power 3, and area 1, which is 2400. So let us check that. Go to element attributes. So your material number is 1 and the section is also A1. So A1 is what we entered as 2400. So just click OK. Now go to auto number through nodes, select point 1 and point 2, click apply. So click OK. So now let us go for again element attributes. Change your second element. My second element is having material number 2 and section is A2. A2 is around 600 mm square. So I am changing these two values. Now click OK. Through our nodes, select 2 and 3, click OK. So modeling is over. Now we'll proceed with loads. Let me go for loading. define load. So node number 1 and 3 is fixed. So go to apply, structural, displacement, on nodes, select 1 and 3. So we have selected two nodes, click OK and click all DOF. Everything is fixed. That's why we give all DOF. Click OK. So this part is over. Next, we are going to apply force. We go to structural, instead of displacement, go to force on nodes. So nodal point 2 is having a force of 200 kilonewton. So select nodal point 2, click OK. So it is asking Fx. So Fx direction is correct. So it is 200 E3. So kilonewton, converting kilo into Newton. So that's why it is 10 power 3. Click OK. So this part is over. Now we can go for solution, solve, current load step. Let me click OK. So your solution is done. Let me go to general post processor. So to look after our results, go to read results, first set. So now to read the first set of results. Next, go to list results. In list results, go to nodal solution, select DOF, displacement vector sum, click OK. So now you can able to see the same value what we achieved in solving manually. So you can able to get the same value here. So it nodal point 2, so you are having 0.232 mm displacement.